Problem 1. X and Y are independent with fx of x equals to u of x minus 1 minus u of x minus 2. Fy of y equals to u of y minus u of y minus 1. Z equals to x plus y. Find the density function of Z. Question 1. Use convolution method. Fz equals to fx of Z times fy of Z equals to integral negative infinite to infinite fx of alpha times fy of Z minus alpha d alpha. So we plug in fx and fy equals to integral negative infinite to infinite u of alpha minus u of alpha minus 1 times u of Z minus alpha minus u of Z minus alpha minus 1 d alpha. It's equals to integral negative infinite to infinite u of alpha times u of Z minus alpha d alpha minus integral negative infinite to infinite u of alpha times u of Z minus alpha minus 1 d alpha minus integral negative infinite to infinite u alpha minus 1 times u Z minus alpha d alpha plus integral negative infinite to infinite u of alpha minus 1 times u of Z minus alpha minus 1 d alpha. It's equals to integral 0 to Z u of alpha times u of Z minus alpha times u of Z minus 0 to Z minus 1 u of alpha times u of Z minus 1 minus alpha d alpha times u of Z minus integral 1 to Z u of alpha minus 1 times u of Z minus alpha times d alpha times u of Z minus 1 plus integral 1 to Z minus 1 u of alpha minus 1 times u of Z minus alpha minus 1 times d alpha times u of Z minus 2 times d alpha here. So it's equals to integral 0 to Z 1 times d alpha times u of Z minus 0 to Z minus 1 times d alpha times u of Z minus integral 1 to Z 1 times d alpha times u of Z minus 1 plus integral 1 to Z minus 1 times d alpha times u of Z minus 2 equals to Z times u of Z minus 2 times Z minus 1 times u of Z minus 1 plus Z minus 2 times u of Z minus 2. Since we shift the result to the right by 1, so Fz equals to Z times u of Z minus 1 minus 2 times Z minus 2 times u of Z minus 2 plus Z minus 3 times u of Z minus 3. Question 2. Use geometric method. First, when Z less than or equal to 1, the graph is Fz of Z equals to probability of Z less than or equal to Z equals to probability of x plus y less than or equal to Z. So it's equals to Z squared over 2. And the density function of Z is d over dz Fz of Z equals Z. When Z greater than 1 and less than or equal to 2, the graph is so Fz of Z equals to probability of Z less than or equal to Z equals probability of x plus y less than or equal to Z equals Z squared over 2 minus 2 times Z minus 1 squared over 2. It equals to 2Z minus Z squared over 2 minus 1. And we can get the density function of Z equals to d over dz Fz of Z equals to 2 minus Z. When Z greater than 2, the graph is the distribution function of z is 1, and the density function of z should be 0. So we can get the graph of density function of z. So we can get the density function of z is z minus 1 times u z minus 1 minus 2 times z minus 2 times u of z minus 2 plus z minus 3 times u of z minus 3.